The Charles Hatchett Medal, cast in niobium metal, is a prestigious award promoted by the Institute of Materials, Minerals and Mining, IOM3, and is sponsored by Brazilian mining company CBMM, Companhia Brasileira de Metalurgia e Mineração. Charles Hatchett was an eminent fellow of the Royal Society who discovered the element niobium over 200 years ago, and its unique properties have subsequently earned it a special place in the history of steel development, particularly in the last century. In fact, niobium was first added to stainless steels to improve weldability over 80 years ago. The Charles Hatchett Medal is awarded annually to the authors of the best recently published paper on the science and technology of niobium and its alloys. The winning 2015 multi-authored paper describes an innovative approach to the metallurgical design of ferritic stainless steels, and we will learn more about this later. The research was carried out by a multidisciplinary team from Germany and the Czech Republic. The winners of the award were presented with their medals during the IOM3's Premier Awards dinner on the 14th of July in Kensington, London.
For me, that's really nice and impressive. Especially because now we're in line with a great row of former winners, and this really feels good.
Yeah, I'm greatly honored to be one of the winners of this prestigious award, and I'm especially glad to having been part of the team who elaborated the work. And I think this award will provide us increased international visibility to boost our future research efforts on this topic.
Yeah, as my colleague said, I feel honored as well. And actually, I was just lucky to join the team in the right time because I made just analysis of results that were already done and some modeling, and yeah, therefore I'm here.
Yes, the selection committee of this award made the best choice with this paper which has been selected because all the people who worked in the institute which have contributed in different ways to this type of development are mentioned there in this paper. And also a co-worker from a company what is mentioned here, Mrs. Huttendorf, for example. So that everybody who has significantly contributed in different ways to this development is included.
In recent years, it has also become customary for CBMM to host a seminar for specially invited delegates the day after the IOM3 dinner and medal ceremony. These seminars aim to focus attention on the broader area of science and technology relevant to the award-winning paper. Ferritic stainless steels represent a strategically important growth area globally for a wide range of applications, and we will shortly hear about many of these from invited speakers who kindly agreed to participate in this year's seminar. Under the banner, The Role of Niobium in Advanced Ferritic Stainless Steels, Building a Sustainable Future, the 2015 Charles Hatchett Seminar was held on the 15th of July at the Royal Society of Chemistry's Burlington House in Piccadilly. Over 50 invited guests of CBMM from 12 countries attended this prestigious event and were warmly welcomed by Nyla Croft, who is the international coordinator of the Charles Hatchett Award. Nyla briefly described the origins of the award and the procedure employed by CBMM's panel of international experts to select each year's winning paper. She then proceeded to make a short general presentation on the role of niobium in advanced ferritic stainless steels, touching on key applications in household goods, structures, industrial plants and transport. Nyla then introduced Marcos Moll of the SMR, the Steel and Metals Market Research Center in Austria. The world market for stainless steel is growing rapidly and is currently around 30 million tons per annum, and Marcos presented an extremely informative and authoritative review of the breakdown of world consumption and trends. 15 of the top 20 world producers of stainless steel are based in Asia, and in fact China alone accounts for about 50% of world consumption. Ferritic stainless steels, which contain either no nickel or much lower levels than austenitic stainless steels, are growing in popularity as a result of increasing nickel costs and have already gained a 30% share of the stainless market. The most common variants contain either 12% or 17% chromium, and specific sectors such as automotive are growing at 7% per annum. The most common variant, which Marcos described as the ferritic workhorse, grade 430, is a 17% chromium alloy containing less than 0.75% nickel. We will see later how a niobium addition can provide ferritic stainless steels with enhanced combinations of strength and toughness, and Marcos also indicated how the use of niobium and molybdenum together could optimize high-temperature properties. Ferritic stainless steels make sense, as they save substantially on key alloying elements, and thus make a significant contribution to the sustainable use of world resources. Bernd Kuhn of the Forschungszentrum Jülich GmbH Institute for Energy and Climate Research in Germany was then invited to present the 2015 Charles Hatchett award-winning paper on behalf of his co-authors. By way of background, Bernd explained how world energy demand over the next 15 years is anticipated to rise by 50%, which would place additional efficiency demands on current and future power generation plant. Increasing efficiency can be obtained at higher operating temperatures, which require steels with higher chromium levels to give the necessary steam oxidation resistance. However, without taking additional measures, creep strength could be substantially reduced, negating any potential benefits of attempting to operate at higher temperatures. Bernd's presentation continued to describe how, by optimizing the balance between tungsten and niobium in ferritic stainless steels with around 17 to 20% chromium, creep strength could be maintained or improved. Niobium enables this by increasing the volume fraction of Laves phase and by refining particle size and thermal stability. Through this development route, the award-winning authors have demonstrated that creep and steam oxidation resistance at 600 degrees centigrade and above are much superior to 9 or 12% chromium ferritic steels, and in the case of steam oxidation, resistance is of the same order as that available from much more expensive high chromium austenitic stainless steels. By manipulating and optimizing thermal processing, alloy variations which exhibit adequate creep strength at up to 650 degrees centigrade can be achieved. This represents a remarkable breakthrough with this class of ferritic stainless steel. Finally, Bernd outlined an ongoing program for the development of compatible welding electrodes for the advanced variants of the new alloy designs. Naylor then welcomed Laurent Fèvre of Apparam-Isberg, France, to the podium to present a paper concerned with the development of a new ferritic stainless steel with improved thermomechanical fatigue resistance for exhaust parts. Laurent explained that increasing focus on pollution control and improvements demanded by new Euro standards were resulting in increased gas temperatures in automotive exhaust components, such as manifolds and turbochargers. Gas temperatures between 1000 and 1050 degrees centigrade are likely to be encountered. The existing optimum material, which already contains niobium and titanium, grade EN 1.4509, can only withstand temperatures up to 950 degrees centigrade. By increasing the chromium level from 17 to 19% and adding 2% molybdenum, the niobium alloyed variant can meet the increased service demands. Enhanced tensile, fatigue, cyclic oxidation and creep properties are all achieved. Mechanistically, the nature and distribution of the niobium-rich carbides is changed, providing a cost-effective solution in which the niobium still provides stabilization against high-temperature sensitivity to localized chromium and weld decay. Nancy Badu of the Steel Construction Institute, UK, was then invited to present her paper on ferritic stainless steels for construction applications. Introducing her presentation, Nancy explained the way in which the Steel Construction Institute interfaces with the supply chain in the UK. The SCI provides standards information, supporting guidance, fabrication and erection specifications, etc. She indicated that the Institute aims to influence designers and specifiers in favour of steel. Turning her attention to stainless steels, she used examples from the built environment and industrial sectors to illustrate potential benefits for stainless steels when lifetime cost considerations are taken into account. One example cited was of hand railings in a marine environment, where the long-term benefits of stainless provided clear and ongoing maintenance cost benefits after just 15 years of service. Nancy continued to explore areas where ferritic stainless steels could be used to advantage in place of much more expensive austenitics, and used examples from Australia to validate her ideas. She also explained that in some circumstances, ferritic stainless steel could be a long-term economic competitor for galvanized mild steel. Finally, with reference to the stress-strain tensile behavior of ferritic stainless products, she indicated how their higher strength and lower continuous yielding could be used to maximum benefit, including for fire resistance up to at least 600 degrees centigrade. Nyla then introduced Yang Weihao of the Shanghai Mitsubishi Elevator Company in China. Yang presented an interesting paper on the use of high surface quality niobium-bearing ferritic stainless steels for elevators. Yang introduced his subject in dramatic style, with a view of the 632-metre-high Shanghai Tower, which boasts the fastest elevators in the world. They travel at an amazing 18 metres per second. The market in China for stainless steel is growing at a remarkable rate, and Yang's company has been number one in the elevator supply chain for 22 consecutive years. Yang described the aesthetic and practical advantages of stainless steel for many different elevator components, and also explained how its ease of formability contributed to its growing popularity. Ferritic stainless steels, microalloyed with niobium, already have a niche market in the elevator sector through grade B443NT, which has no nickel but higher chromium than the competitor austenitic 304 grade. The ferritic option has similar tensile properties, comparable corrosion resistance, but enhanced formability. However, using additional niobium at the 0.3% level in combination with copper up to 0.4%, a new, finer-grained steel has been developed with significantly enhanced tensile properties. The enhanced steel, grade B443NB, has already been successfully utilized in many different types of lifts and is saving up to $4.2 million per annum through weight saving and other advantages. Research is ongoing to maximize the benefits which can be derived from this latest addition to the ferritic stainless steels family. The final speaker at the seminar was Andrew Backhouse of Outokumpu Stainless, UK, who presented a paper outlining future developments in stainless steels containing niobium. Andrew opened his presentation by reminding the audience that his company's base in Sheffield was the birthplace of stainless steel through Harry Brearley in 1913. He then went on to describe Outokumpu's world market penetration in the stainless market, indicating that 19% of their market was already accounted for by ferritic variants. Austenitic grade 304 is all around us in everyday applications, but the ferritic 430 grade is an increasingly important competitor in the UK market. Now, with further development, new improved grades of ferritic stainless steel are available, and these have better corrosion resistance and enhanced weldability. Alloying with chromium up to 21% and using titanium and niobium additions of up to 0.7% has enabled the development of a cost-effective and much improved ferritic stainless steel. This is more formable and weldable, with corrosion resistance equivalent to that of austenitic materials, but with the enormous benefit of using no nickel. Thus, ferritic stainless steels are poised to continue to penetrate the austenitics market at an increasing rate, whilst making a major contribution to the sustainable use of the Earth's scarce resources. Stainless steels are also 100% recyclable, which, as Andrew points out, is a further important factor in the current climate. At the end of a very informative seminar and an excellent open exchange of technical views and opinions, Eduardo Ribeiro, Chief Operations Officer of CBMM, once again thanked all the speakers and invited guests for their participation. The global stainless steel growth story is remarkable and shows no signs of slowing down, particularly in Asia. With their attractive combinations of properties for an ever-increasing range of applications, ferritic stainless steels, especially those microalloyed with niobium, are well placed to continue their relentless penetration of the austenitics market, and in doing so will make a meaningful saving to the world's consumption of nickel and to the sustainable use of our finite resources. There is a bright future for niobium in stainless steel.